Bonjour. Hi, I'm there. Nobody's there for the moment?
Hello.
Hello. There is an echo. Is it normal?
Yes, the sound works well from online, I think.
The session is yet to start.
They're having lunch in Berlin. Nice.
Café en
Yeah, in that case, they'll make a quick coffee as well.
Hi, Stephanie. When are we supposed to begin?
Around.
It's really difficult online because there is a very, very strong echo.
Can you hear us online?
Yes, it's better now.
Yeah, okay. So we will start in a few minutes.
Okay.
Yeah, already, and just make an hour, and then we just have questions. Yeah. And so we will just see, and I think we make an hour lunch break. So we will go back to the about 1:30. Yeah. So you can also write your chats after 1:30 we go to the Berlin. Yeah, to Berlin 1. Yeah. At 1:30. Ja.
At the end.
Wanneer dieses wieder ist. Das sind immer so eben mit der jedes
You have to be at two sessions at the same time.
Yeah, I will start here and then
All right.
the other one.
So I would already start. I would like to welcome you in the room Kyoto. So my name is Marijke Vunink, and I will be the moderator of this session together with Alwin and Isabel, who is online. So each project will present a presentation of 10 minutes, and after each presentation there will be the opportunity to ask some questions. So the people on the online are encouraged to write down their questions or raise their hands to speak. So we are here today to listen to the projects of FOSC. that contributes to a resilient and sustainable food system under change. So we start first with the online presentation of SIAM, Integrated SIA and Oyster Mushroom Systems for Sustainable Food System Value Chains in Africa. I hope she's in the right room. Will I just see? I do not have the name of the representative, so.
Mariska, if I may just say some words.
Can you hear me?
Yes, and you, can you hear me?
Yes, we can hear you.
Yes, just to present myself, I am the coordinator of FOSC, and I am very pleased to see you there today. Just to remind, and I will put it in the chat, that we will have our FOSC meeting in Marrakesh next week, and that if you are not registered and if you want to participate, there are 2 sessions for researchers. The first one on the 16th for research outputs, and the second one for training on the 17th, with 2 interesting sessions, one about networking and the second one about science diplomacy and freedom in research. If you are not registered, I will put to you the link in the chat, and you are welcome to participate. Very pleased to participate to this session and to see your result. Thanks so much for your participation. Best.
Okay, thank you, Isabel. So now we start with Dr. Monica Member.
Yes, I'm here.
Yeah, so I will share your presentation to make it smooth. You have to say next if I have to go to the next slide.
Okay, thank you. Thank you. Good morning or afternoon, everyone. I'm Monica at the Dankimadi University in Nyeri. Our project is on integrated chia and oyster mushroom system for sustainable food value chain, and I'm happy to be here. Next slide. Yeah, I'll use this outline as any other presenter. I look at why chia and what we have been in, who are the partners, the objectives, and our findings. Next, please. Yeah, thank you. We ask ourselves why chia. Why did we look at the chia and we integrate with oyster mushrooms? It's because both of them are superfood. And looking at the African food system, we are quite poor in terms of the type of food we eat on a daily basis, which we call staple food that is very rich in starch. And so bringing in chia and oyster mushroom, it's a way of incorporating essential nutrients that are beneficial for human body. And in this way, we address the issue of hidden hunger, where Africans are eating a lot of carbohydrates and they fail to take enough nutrients in terms of protein and minerals and vitamins. And by incorporating these, we were able to upgrade the nutritional status at household level, where by growing chia seeds, which after harvesting, we use the chia for making specific products and also fortifying the local products. And the biomass we get at the farm, we grow the oyster mushrooms, where after harvesting, we also use mushroom for fortifying the local food. And the waste we get at the farm, we use it to complete the circular system. So by using chia and oyster mushrooms, we successfully fortified the ugali. What you see at the top there is a maize gruel that we consume here in Kenya. It is made of maize, and so it is very rich in carbohydrates, but fail to have other nutrients. So we were able to incorporate chia and in some formulation and others oyster mushroom and come up with a good formula or a product that was acceptable locally. And also what you are seeing in a calabash is our porridge that is taken by the infants and old people. We also managed to fortify that. So we can say that chia helped to upgrade our nutritional status locally, and also to look at how we utilize waste at farm to create other systems that are necessary for our systems. Next, please. Okay. These are the partners. We had partnership from Germany, that is the University of Hohenheim, where we did a lot of product development and analysis. 2 partners from Hungary, that is Pius Nagy and Bay. Those are experts in oyster mushrooms. They helped us a lot to be able to set up our production here in Kenya. The Kimathi University, where I am, and we are the coordinators of the project. And also in Kenya, we have Kirio Farm, where it is a mushroom producing farm. And then we had partners from Morocco, Algeria, and Egypt who are benchmarking with us and also helping in testing the growth of chia seeds within the African system. Next. Okay, our main objective was to demonstrate a climate smart farming system, that is a circular system, by incorporating the 2 superfood, that is the chia and oyster mushrooms, and trying to create new agricultural technologies whereby into the existing African agri-food value chain, so as to increase resilience, sustainability, and circularity. So we successfully achieved this at the end of the project. Next. Okay, so looking at the first specific objective, we were looking at the improving the chia seeds production through breeding that successfully happened in Egypt. We had our breeding expert in the Agriculture Research Center in Egypt, and we were able to come up with a new variety of chia, that is the Misri one, that is doing well in Egypt, which is a dry area. And now we are about to test it in Kenya. In Kenya, we have been producing chia using the locally available material, which we buy from the market, but now we'll be using this variety to test within our Kenyan soil. We also managed to develop an agricultural mobile application that is able to register chia cultivation and other correct data about the production of chia and oyster mushrooms, which is very beneficial for farmers who use this to be able to get information on how they can enhance these at their farming systems. Next. Our next objective, we successfully fortified local food with chia seeds and oyster mushrooms. That is, a lot of work was carried out in Egypt, in Germany, that is the Hohenheim University. We were able to have our researchers go there to test and to fortify our local food and do the necessary analysis. And we would say that we have been able to commercialize the chia products and oyster mushrooms and incorporate them in other products within the system using a startup company that we have successfully started within this project. Next. We also now use the biomass, the waste we get from chia production and also mash production. We use this waste for animal feeding and also for organic farming. And so looking at valorization of the waste streams, we were able to transit to circular economy, where the smallholder farmers that we incorporated in our project and have trained, they were able to incorporate the agriculture waste we get from the chia and other biomass within the farm to grow mushrooms and produce biogas and so get biofertilizer. So it is not now farming as usual as we have done it traditionally in Africa, but this has improved using this waste material. And so with the spent mushroom substrate that was fed to pigs and other animals, the waste we get, we set up a biogas system that has successfully worked well, and the biofertilizer or the waste from the biogas is used for production of not only mushrooms and chia, but also other vegetables and herbs and fruits within the farm. So that way increasing biodiversity within the farm. Next, please. So we've come up with innovative ideas of linking the chia and oyster mushroom, integrating the two, which we term as superfood within our system. We have also been able to utilize waste and build a circular economy. And we can say that out of the work that we have done here, because the setups were here in Kenya, we were able to know that a kg of fresh oyster mushroom result in like 5 kgs of spent mushroom substrate that was being used as organic waste within the farm. Farmers use it for growing their crops, that is organic farming, or incorporate it to animal feeding where you have the biogas production. So this successfully happened here within Kenya, and we were able to test with the smallholder farmers. Next, please. Okay, so we would say that out of what we have done, we have been able to reduce the environmental footprint, which is something that can be adopted by the policymakers to be able to enhance our African farming systems and also look at issues of climate change mitigation. And by growing the mushrooms and using the spent mushroom substrate for farming and also incorporating into animal feeding, we've been able to increase production within our farms and also to create biodiversity. So they have better farming methods, and that way we enhance the food and nutrition security within our region. Next, please. So we ask ourselves, what next? Because we need to proceed in a way that farmers do not disintegrate back to the traditional farming system. We need to continue building capacity for our resource poor farmers on climate smart agriculture, and also help farmers to accept mushroom as food. That is one thing, because many people locally think mushroom is wild. You know, it's not consumed as food per se. So there's a lot of training that we have done to convince the population, the local people, that mushroom is also a good source of protein, and how we can use the waste we get out of mushroom production to feed animals. And in this case, we tested with the pigs, and it did well, but they did not like it per se. But we have also set up another system of rabbit farming, where we are making pellets and incorporating small amounts of the spent mushroom substrate, which seems to work. And also by convincing farmers to rear rabbits to be able to produce enough manure, it's also an economical way of having source of meat within the farm system, and also improve their soil through the manure that we get from the farmers, the rabbits, and also the urine that is used as foliar feed. So we look for more financial support to be able to proceed with this climate smart agriculture among the smallholder farmers and create better systems by enhancing what we already have put in place, and also encouraging farmers to plant other types of crops that can enhance their nutrition at household level. Next, please. So we would ask, are you ready to roll up your sleeves and join in this campaign that we have set here in Africa for small-scale circular agriculture in a way of promoting food security and environmental sustainability? We would also ask you to maybe join us to let's nourish the change within Africa. And we can see that the Morocco partners and Algeria, who have been benchmarking with us, and those are very dry countries, they have also been able to come up with chia seed production and set up the mushroom production, which are now, they are learning from us, because for us, we have successfully been able to fortify our staple food and enhance what the local people are eating. They are picking up from the same. So we would like to continue with this project. We can't say that we have come to the end, because we still have more work to do, how to look at the spent mushroom substrate, how it can be utilized in a better way within the farming system, and also grow other superfood to enhance our indigenous systems. I think that is the end. Thank you so much, and thanks for listening to me.
Thank you for your presentation, Monica.
Thank you.
I want to know if there are some questions here in the room. Yeah, go ahead.
Hello, my name is Elmar Schroeder-Gelderman. I stayed some time in Kenya, so I know Kenya very well. What kind of requirements does chia have in terms of agro-environment, agroecology to grow it? And did you mix the chia directly with the unga flour, or was it added later in ugali in the preparation?
Okay, thank you for that question. One thing I would say is that before we started this project, I was running another project where I promoted chia within the region, and it did very well. It grows within the same climatic status, but it requires a lot of water. So we plant it during the 2 rainy seasons. We have 2 rainy seasons here in March and October. Those are the seasons when we plant chia, and then we keep that in stock for use later. So on the agronomic part, it's doing well locally. I think it has the same climate as other regions of the world where it is grown. And when we use it for fortification, first for it to be added to the maize flour for the ugali, we have to defat it. So we subject chia to cold press for extraction of the oil, and the oil is very rich in omega-3, which we pack as essential oil. And the cake we get is what we use now for fortification, which is like a protein concentrate, so that the flour has better keeping quality, doesn't go bad within a short period of time. Thank you.
Yeah, we had another question as well.
Yes, I do. Thank you very much for your presentation. I saw towards the end of your presentation that the economic aspect of the project is about to begin. And I think I have just a very minor question. Did you create a new value chain for chia? So I will admit here I'm ignorant a bit about chia cultivation and if it's something that is common in Kenya. And I was wondering if you created a new value chain for chia now, or you upgrading an already existing value chain. So, for example, by introducing the new chia variety that you talked about, and
Okay,
what the implications could be now for smallholder farmers.
Okay, thank you for that question. What we would say is that first we started by incorporating chia into existing products that are there. Like we have successfully used it in maize flour. We have also incorporated it in yogurt. We have chia yogurt, but we are also trying new ideas like the cake, which is rich in protein. We can have other new value chains for protein concentrate and other products that we are now testing. They have not successfully been launched, but we are in the product development stage. For the incubation with farmers, the farmers, because they are small scale farmers and in mixed farming, they have cattle, they have other types of the plants and anything else. We help them to incorporate chia into what is existing. Like if a farmer has enough milk, we train them on how to make yogurt and incorporate chia, and other also to use chia at household level. So we are just using the existing value chain to enhance with the chia and its benefits, and also oyster mushrooms as well.
Thank you very much. I have a follow-up question. Is that okay?
Yeah, that's okay.
So for the products that you get from the chia, from cultivating chia, do you intend, are farmers going to be the ones selling the products, or do you intend to link them up with supermarkets and other retailers to help sell their products?
Okay, at the university, we have started some startup companies. We have one startup company that is using chia as a raw material to make different products. That way we buy the raw material from farmers. So they produce, they sell to processing companies to be able to take it to the market, because themselves, they may not have the capacity. And we have laid that platform by having a startup company at the university that is processing commercial products of chia and oyster mushrooms.
Thank you very much.
Okay, thank you. I see there's still one question in the chat, but we need to go through the other project to give them equally time. So I would ask you, Monica, to answer the question in the chat, if possible. And then we go to the next presentation, and that's peeling, and that's presented by Hervé van der Schuren from the KU Leuven.
Do I stand there or?
Yeah, you can.
Yeah,
you can stand here and
I can sit as well. What is expected?
No, you can stand here.
I don't want to take your.
No, it's fine. But I think there's a problem. Okay. Perfect. Then I need to see how I can do that in presenter mode. And it's all in German, so I'm really not sure what I need to do. Yeah.
Anzeigen.
Yeah, that one.
And then,
Yes, that one.
yeah. Okay. So it's up to you.
Thank you. Do I need to talk in a microphone or just here?
Just here, I think.
People are hearing me?
Yeah, they are hearing you.
Okay. Thank you for joining this presentation. So many people from the beach I can see, but I guess there are many people online. I'm here to present the Feeling project. As I was explained during the pitch session, the idea is to try to improve healing. I will show you that there's also another component, but the main component is about healing in plants, a concept that is, I would say, relatively new. I should also insist on the fact, I think it's also the place here to discuss about the importance of developing, let's say, advanced studies in some minor crops or so-called orphan crops like cassava, a very important food security crop, but for which we have very limited knowledge, very limited investment from the private sector, simply because this is a poor man's crop and nobody really cares too much about this crop. So I think it's also the role here of this, or the strategy of this project is also to build some more knowledge on this very important crop. I wanted to start with what I explained in the pitch as well, is that there's a big divide or a very big difference between countries or continents in the way we are handling crops after harvesting, or the way we harvest and the way we store them. This is now a visit we had with a partner in South Africa, where we see that, of course, there's a value chain is a bit more established if you compare to Kenya, which is another partner country in the consortium. So we do see, of course, that having capacity to store properly the vegetables or properly the food crop, of course, makes a difference in terms of amount of losses that we have. Yes, so just to illustrate a few things we had in South Africa, and here you see now harvest in Kenya, and this is quite different, as you can imagine. There's limited storage, there's long distance often, production happening in remote areas, had to be brought to the markets, and of course during this period, high humidity, high temperature, of course, create extra problem in terms of storage. So if you look at cassava, one of the and this is the reason why we are focusing on cassava when we talk about healing, there's a major difference between potato, as you can see on the top part, although you see here some bacterial disease in there, but potato and cassava has kind of a different capacity to heal. Actually, potato is actually a good, it's a tuber and it can heal relatively well. So if you cut a potato, you will see on the next slide, you do see some kind of wood peridot that establishes, and therefore you prevent entry of oxygen into the potato. Cassava does not have this capacity, and therefore it's much more susceptible to some kind of oxidative stress after harvest. It's also very difficult to harvest cassava without creating wounding, because you have to remove this from the plant. You have to see that farmers are digging holes next to the plant and, of course, damaging the roots and creating entry points for oxygen. I think I don't need to come back to this. So it's a big difference. If we look at losses, maybe a concept that's interesting to have. We have similar losses. If you look at African continent and the European continent, we waste a lot of food once it's in our fridge or once it's at home. We have no problem to trash very good food, right? Because we don't manage this very optimally, but we are quite good in bringing all these foods to the fridge. That's quite good in Europe. In Africa, it's completely the opposite. It's very hard to bring this to the fridge, if there is any fridge, of course. But then people say, "Oh, do not waste food at home." So it's a very different concept, and it also means that helping this value chain, helping people, the farmers, to bring good food to the fridge or to the consumer is the key challenge on the African continent. Yeah, so the project objective is indeed to increase our knowledge about how plants can heal and use this as a way to mitigate food losses. I should also mention that the South African partners are also interested in developing technologies to reduce bacterial contamination onto this food during storage, which is another complementary, let's say, approach that is also quite essential besides healing. So we will focus on genetic diversity, whether there is some variation there. But you have to always keep in mind that human beings, over the course of the agricultural developments and selection and domestication of plants, they have basically selected plants that are high yields. They want to get food and not necessarily having good performance in terms of storage. There was, of course, a very long period where there was no capacity to store, so basically people were just basically harvesting and consuming. So I think this slide is quite illustrative of what I want to show you. What you see here is actually in a fruit crop now, in tomato. What you see on the left-hand side, you see that if you use some dyes, you see that directly if you apply dyes on the tomato that you harvest, you see that the dye is directly diffusing into the fruits. So it means that other molecules, of course, can go in or out. Water, oxygen, as I said before, can enter directly the fruit. If you do this 4 days later, you see that the plant or the fruit in this case has sealed itself. So it means that you don't get any more diffusion of small molecules into the fruit. So that's a very important mechanism for plants to protect or to save, in this case, the seeds for dissemination. So again, as I explained before, what you see here is what's happening in potato, which is closer than tomato to cassava, although still a tuber and not a storage root. You see here that over time, 19 days after wounding, you start to see a periderm that is coming back. So it means there are layers that are basically accumulating there and preventing oxygen to enter and preventing also water losses, which is another important phenomenon happening in potato. It is very important to have this mechanism in cassava because cassava has extra susceptibility, what we call the post-harvest physiological deterioration. It means it's a very big limitation for cassava production, for farmers, growers, consumers, because within 48 hours after harvest, because of oxygen entering the roots, you have the so-called vascular streaking that we have in the roots. So it means that the quality of the starch is declining over time and very quickly, meaning that for growers, for example, I can give you the example that if you produce some cassava in the countryside in Kenya and you bring it to the market, you bring it within a day, you have the full price for this cassava, but if you bring it within 2 or 3 days, then you have a price decrease of 80% for the farmers. So this is a very important phenomenon because nobody wants to buy such a damaged root or such a decaying roots, as you can see. So the idea here is to think, is there any genetic diversity to prevent or to heal faster so that there is less oxygen entering into the root and less symptoms? Again, I will not go into the detail because I think it's here probably not so technical. I think it's more the concept. What you see here is that we've been screening cassava genotypes used by farmers to see whether there's any diversity in accumulation of suberin, which is the key molecules to seal, so to do the wound healing. And also we are looking at the composition of the suberin. Is there any link between the composition of the suberin and the capacity to heal? So we can select, of course, criteria with more or less different levels of suberin. You have to keep in mind that this is done now on the full roots, and this is also not necessarily fully representative of healing. So it means we also need to develop protocols to induce wounding and to induce healing. But still, we can see that in the composition, we do have some variation between those different genotypes. We still need to link we still need to link this to the performance, of course, of those cultivars, which we are also doing with farmers in the field. What you see here is a kind of easy method to, let's say, fingerprint the accumulation of those suberin in the different genotypes. And we've developed this method now to also enable breeders, for example, to select cassava that would have the right fingerprint in terms of suberin accumulation in the roots. As I said, we also do with Kenyan partners, we do evaluation in the field. So what you see here, we define or we detect or we can characterize some of those varieties that do perform much better than others. You see here after 7 days, you see quite a big difference between different genotypes. So there is some variation that is present, not necessarily always connected to suberization, but can have some link with suberization, as you will see. So here you see again the selection of the best performing or the most performing, or let's say more different performing genotypes in terms of PPD development in those roots. So you see that some can stay for 21 days, so 3 weeks. That's quite good actually. You have to keep in mind that you might find some very interesting genotype, but if the quality of the starch is not very good, if the taste is not very good, you can tell the farmer, please grow this one. But if he doesn't like it, if nobody wants to eat that one, it's not going to work. So it's also very important when we do this characterization, and this is for the molecular work that we are doing, to try to understand what is behind this trait, because we know that eventually it will be up to the breeders or to the biotechnologists to develop varieties, cultivars that farmers do like and that are also performing well. And very often those traits are not combined or not correlated. So as I said before, genetic engineering is very important. So we need to understand what is happening, and this is also what we have done. We have done some so-called RNA-seq analysis, so trying to understand how the genes are being expressed during this phenomenon and trying to identify something that are deregulated during supervision. It's a very complex mechanism, as you can imagine. It involves many genes. So one approach that will also be taken there, again, I don't want to go too much into details, but we have focused also on transcription factors that are known to
Yeah, this one.
Maybe you can make it smaller. Maybe.
Answer the session. This one, yeah. This one.
Yes, directly.
Yeah. So maybe you can make it smaller, that it's not visible. So yeah, it's gone. So I'm not sure.
So here, concretely, we are trying to identify transcription factors that do control the expression of many different genes, because of course it's a very complex trait. So we know the genes that are involved in suberization, production of those long chain molecules that are involved in suberization, and trying to understand whether we can have activation of certain genes with those transcription factors. This would give us some idea or some potential for genetic manipulation, basically, or even for classical breeding, if we can find the right mutations involved in those regulations. Those projects, FOSC is also always about impact. So we also have to think about, okay, can we link directly to the farmers? We know how difficult it is to link this research to farmers. But we also had some thinking or ongoing research in the lab that also looks at a more practical solution, or let's say something that has a higher TRL in terms of implementations. And while we're very interested to characterize superization in cassava, we also know that when industry is processing cassava, so there is starch industry processing cassava, they actually peel off the roots, and those peels are usually used either for animal feeding or for bioethanol production. But actually in those peels, you have those molecules, those biopolymers, like suberin, that are actually accumulated there because they prevent indeed exchange with the environment, so they prevent water, oxygen to diffuse from the roots to the environment, or vice versa. So there is also there some potential. We've published this work where basically look at the content of suberin in those potato peels and the cassava peels, and trying to identify the possibility to use those biopolymers or extract biopolymers to use it as a coating agent. What you see is indeed the possibility this characteristic that we have from the peels to prevent entry or diffusion of water through the berry then. And so this is what we have been using or extracting in order to develop some kind of coating agent. I will skip that one because I'm a bit late. This is what you see in the future application we have here. We published this work. So what we've seen here, we use here tomato and berries as a model. We've extracted suberin from those peels, and we've used those extracts, so those suberin extract, to coat tomato and berries and to measure how it can protect actually those fruits. So actually it's an interesting application that we have developed and that we have patented. So it means that we can use basically extract from the peels in order to develop some kind of solution to protect other kind of produce like berries and tomatoes. But that could also be have an application directly to recoat actually cassava that has been extracted or that has been harvested, I should say. So that's another interesting application we have. We're also looking at a more direct effect. So we know that, as I said before, we know the genes that are regulated during suberization. So we are trying to identify some molecules that might prime induction of those genes, because that could also be an easy solution to, let's say, improve healing in plants and to help farmers with these technologies. I'm behind schedule at first, so I will close. I think I will skip that one. Maybe another important work that has been done as part of the fielding project, as I said before, is the identification of phages. And phages are actually viruses or bacteria. So I think it's another interesting application. Probably can be actually combined, phages and coating, as I explained before, with suberin. So in this case, we are trying to, the team in South Africa is identifying some phages that are able to basically eliminate those pathogenic bacteria that are sometimes present on produce like potato and tomato, for example. I will go, not go too much into the distance. It's very into this slide, very important because it's actually, we are targeting multi-drug resistant bacteria for which we need some kind of solution, otherwise causing major trouble for people feeding on those products. Okay, with this I will close. I hope I could present you had all the concepts that I could present here, some pictures when we went to the field in Kenya, but also in South Africa. And yes, I'm happy to take some questions about this project.
Yeah, thank you very much for the presentation. I'm not sure if there are some questions here in the
I
audience.
would have, but the time is running out.
Yeah. We still have after this one presentation from Salad, so the other one, Swiss Agri CC, was not present in the. So I think there is.
The problem is that I have to leave for the other session.
We just move on to the other project.
So you can ask a question maybe now, and then we. That will be.
One question: did you work with IITA?
Oh, we have collaboration with IITA, of course, on many different aspects, but not as part of this project. As you, we can discuss this in the break. But these are small funding research here. IITA is becoming, of course, is a center that requires a lot of funding, and so it's very hard to collaborate as part of those kind of projects.
I used to work at SIP.
Okay, completely interesting. Yeah, SIP we don't work directly with.
But I was in the wheelchair with bananas.
Okay, so we will move on to Salad's presentation. Will be held online and it will be presented by Katarzyna.
No, I'm taking over from her, unfortunately, but she will join to Marrakesh for the FOSC course. You can meet her there.
Okay, great. Sim,
Yeah.
I give the word to you and you have to say it next if I have to go to the next slide.
Yes,
Yeah.
thank you so much for your assistance. I'll try to better time manage this presentation. It's never been my strongest skill, but fingers crossed. So today I would like to tell you a little bit about the SALAD project, which is a really cool acronym, which stands for Saline Agriculture for Adaptation. In my short pitch, for those who are already there, I talked a little bit about salinization and left you on a little bit of a cliffhanger. So I'd like to tell you a little bit more about what we actually did and what future we see in front of us. Next slide, please. I also got to say, I work for the Vrije Universiteit Amsterdam, so I represent the Institute of Environmental Studies there. What you see in front of you, I'm not expecting you to all speak or understand Dutch, so I'll take you through the pictures a little bit. On the first picture, you can see a potato field on the island of Texel. We have some islands in the northwest of the Netherlands, and they have a lot of salinity problems due to various reasons. I'll talk a little bit more about that in a bit. So in the Netherlands, we are starting to have extreme droughts, quite frequent. 2018 was one of them. And because of that, there was a water shortage, but also the salinity concentration in the soils increased quite a lot. So you can see all these potato plants that have withered in the fields of Texel, and the yield was also pretty much zero in that area. Now, in the right, that's the Haarlemmermeerpolder, that's in North Holland, pretty close to Amsterdam. There was also a saline patch. What's important to know about salinity is that's quite a heterogeneous problem. So within one field, you can have very salty patches, whereas in between, there is not really a salinity problem. So every salinity problem really has to be assessed and solved on a very small scale, which makes it complicated to find a silver bullet problem. Next slide, please. Right. So there are different causes of salinization, which also makes it a bit more complicated. So on one hand, we have climate change, so longer droughts, sea level rise, and because of that, the salty groundwater can come up. That's called seepage. The sea level can also rise and the rivers remain the same. So then through the rivers, you have saltwater intrusion. And then there is also a simple formula of irrigation or rain and then evaporation. And if there is more evaporation than irrigation that comes in, there's always a little bit of salt or of salt ions in the irrigation water, then the salt concentrations in the soil will also increase. It's also very important what type of soil you have. So in clay soils, it's harder to get these salt ions out as well. So you need good leaching and good drainage, because then if the fresh water from the rain, for instance, flushes through the soil, then the salt concentration can be flushed out again. Next slide, please. Right. So we focus in our salad project on the North Sea and Mediterranean regions. We're really happy that through FOSC we could also get project partners from Morocco and Egypt. So we had some very interesting case studies in very different contexts. There are different types of salinity as well. So there are different causes, but also different types of salinization. So you can have irrigation salinization. So if there is a little bit of salt in your irrigation water, it then comes on the plants, it enters the soil, which increases the salt concentration. You also have aerosol salinization. So that's if the salt ions come through the wind. That's usually more in coastal areas, like in Italy. You have flood salinization. So if there is a flood, that like basically flushes the salt water onto the land. And this doesn't always have to come from sea water. In Kenya, there was a river that was flooding a lot, and there were also some ions in there that caused a lot of salt accumulation in the soils around the area. And you have seepage, that's what I talked about a second ago, so that's if it like goes underground. And there are various saline environments, so salinity is not always bad. There are also natural saline environments with high biodiversity, and those have a high value and secondary values as well. Next slide, please. All right, as you see, it's from the US National Park Service. You have salt marshes there. And they're also a bit of a buffer zone, so they can be kind of a protection from the mainland, from floods, from erosion, different kinds of erosions, and they're ecological guardians. Next slide, please. Right, so again, a slide in Dutch, sorry about that. So as I said, the droughts are increasing. So on the y-axis, you see the shortage of rain we had on an annual basis. And you can see that in 2018, 2022, 2023, they were all like in the upper end of the spectrum. And this is the past 120 years of graphs that you see in front of you. So you can see that the shortage of rain is really, really getting concentrated in today. And the projections are not looking great. Next slide, please. Salinization in the Netherlands will become an increasing problem, but also in the partner countries that we work with. Italy, Belgium, Morocco, Egypt, and all throughout the world, this will become one of the biggest agricultural problems that we will face. But there is a solution, potentially, saline agriculture. So it's introducing salt-tolerant plants or salt-tolerant varieties that are a bit more resistant to salt. And I also said previously that irrigation, drainage, leaching are all important factors that can cause salinization, so they can also be part of the solution. So if you increase and improve your drainage, if you increase your leaching, if you have a better irrigation strategy, and this could be drip irrigation, for instance, you could also prevent and solve, in some cases, the accumulation of salt in the soils. What you see in the picture in front of you is a project that happened about 5 or 10 years ago. Salt from Texel, so the islands in the Netherlands I was previously telling you about. There were some scientists that basically wanted to see if different varieties of a potato, of a cabbage, of a tomato would react in the same way to different levels of salinity. And what they found was that some potatoes were quite salt tolerant compared to others. And previously, the FAO, the Food and Agriculture Organization of the United Nations, kind of treated most species as having similar thresholds to the salinity levels. So this was quite groundbreaking. But there are a lot of things that need to happen before you can scale this up. National governments need to be on board, policies need to be implemented, there needs to be a value chain, a market to sell some of these varieties, because maybe they're unknown in local markets. And investors should come on it. And that's where salad came in. Next slide, please. That's where we wanted to do research on, like how can we upscale? And it's quite an interdisciplinary project. So we looked in the biophysical domain, so soil and water interactions. We also looked at stakeholder interactions and the financial sector to see like where the problems, the bottlenecks are and where the opportunities lay. Next slide, please. And some findings of the projects, I will briefly demonstrate them in the following slides. So work package 1, which was a bit more about the biophysical domain and the water-plant interactions. Yeah, side note, I'm not a natural scientist, I'm a social scientist, so I'll try to explain this as best as possible, but if you'd like to know a bit more in detail, I can refer you to my colleagues after this presentation. So what we found is that different levels of compost increases the salt tolerance of the plants. So there was a control, as you can see by the green bar on the left, and then there were also plots with cow manure, goat manure, frass, and it seemed that the yield became bigger and that the stress level, the stress reaction to the salts became lower. We did this on 4 different crops, so tomatoes in the Egyptian context, quinoa in the Moroccan context, potatoes in the Dutch context, and New Zealand spinach, which is a halophyte in the Italian context. Next slide, please. Yeah, and we also looked a bit at crop modeling, and I'm not an expert on modeling, so these are like quite the detailed findings that we had by trying out the SWAP-WOFOS model on salinity. And I think these slides will be shared, so if you want to know a bit more about this, then feel free to read afterwards. This will also be in the SALAD final report, so if you want to know something about the interaction of salt and modeling, there is information from the SALAD project, so feel free to reach out. Next slide, please. Work package 2 also looked a little bit at sensory and nutritional analysis. So we looked at different varieties, different crops that were maybe a bit foreign to certain contexts, and we looked at how participants, how potential consumers reacted on this. Quinoa is quite promising because it's very salt tolerant, but in Morocco, as some of you might know, couscous is kind of a staple food. And quinoa could be a replacement for couscous, which is more vulnerable to salt. And what you see in front of you was a workshop that was organized, and they basically, it was a cooking workshop, so they had all these dishes and staple foods like breads made out of quinoa instead of couscous. And they did research on color, smell, aroma, taste, flavor, and texture, and the perceived tastes were very positive. And also, when asked about if it could be a good replacement for couscous, the reactions were also very positive. So there is a lot of potential to make this into a market and into local supply chains. Next slide, please. I'm almost at the end. Work package 3, stakeholder interaction. So we looked at, okay, so saline agriculture in some contexts, especially in Europe, is kind of a niche still. So what is happening? So we looked at all international corporate initiatives. So those are transnational initiatives that focus on saline agriculture. And we did a bit of an analysis. So what type of institutions are active? What are the connections? Where is the geographic density? And we found that the majority of the initiatives, I think about like 85% of them, included public actors in these initiatives. And the private sector was falling far behind. Next slide, please. So what we could conclude from that is that, yeah, there is quite an opportunity for the private sector to jump on this. Now, what we also did, and this is quite cool, this was not a deliverable by the project, but all the data and the outcomes that we had from this work package, we made into an interactive, publicly accessible map. So I'll share the QR code later. You can scan it, you can go to the website, and all these initiatives that we found, plus their actors, are now mapped on this map. And it also has a knowledge portal. It's very cool. Next slide, please. So and this is the QR code. So if you want to make a print screen or quickly, we can put this up maybe later, then we can go to the website. It's really cool. Next slide, please.
Everybody has it? I will wait 1 second.
Yeah.
Okay, yeah.
It works on your phone, your laptop. And then finally, work package 4, where everything was supposed to come together. So we mapped challenges of upscaling of these different crops in these different contexts, and we paved pathways on how they could be upskilled in their country and crop perspectives. But as also was shown in work package 3, the private sector wasn't on board with it. So we also talked with the World Bank, the WWF, the Asian and African Development Bank on why they wouldn't be so interested in investing in saline agriculture. And yeah, there is a lack of subsidies and adaptation costs. So there is a lot of risks for the private sector, and they're not willing to take all those risks by themselves. So government support could be improved, and they could also be part of the funding schemes that could enable saline agriculture to scale up. And there's a bit of a technological knowledge gap. As I said before, it's quite a complicated problem with different causes, different solutions. Salinity problems are very heterogeneous, so it really requires very in-depth specific knowledge and also technology. You need sensors, you need measuring equipment to solve these problems. And for a lot of small-scale farmers in Egypt and in Morocco, this could be quite a challenge to get over. Next slide, please. And these are final recommendations. So for farmers, the technological knowledge needs to be improved. And this can be done through awareness campaigns, because lots of farmers have declining yields and they're not even aware that it is salinity that's causing this. There are lots of opportunities for women farmers in Morocco and in Egypt, was found through workshops. And policymakers need to get on board. Salinity needs to be on the policy agenda, national and international. And the research community, it's still an early stage, which is exciting but also challenging. There's a lot of things that could still be researched. And business and marketing. There needs to be marketing about saline crops. There needs to be a market for it. There needs to be demand from it, so it can be a profitable operation as well. Next slide, please. Steps forward. Yeah, I'm also out of time, I see, and I could pave a way forward, but I was also curious to see that with the information that you received the past 10 minutes, what you see as step forwards. So that could maybe be a nice starting point for questions and discussions. So that was my little pitch. Thank you for listening, and yeah, I hope to talk with you all in the future in different scenarios.
Thank you, Pim, for this presentation. So I'm not sure if anybody already wants to jump in with the next steps forward. Yeah, I see some hands raised in the, yeah.
I actually have a question regarding methods. So I wanted to understand how you went about to do the stakeholder mapping.
Yeah. So what we did is we basically started with an internet search where we looked at these international corporate initiatives. And our definition for an international corporate initiative was that it needed to have multiple actors active in multiple different countries with a direct or indirect aim to steer a policy. So that was our definition. So that was kind of like our boundary of the sample. And then we created a database, and through also contacting some of these initiatives, we then continued with snowball sampling. And once we reached the data saturation point, we had some expert workshops and we had some surveys to validate whether these initiatives met the criteria that we set up, and also whether on the topics that they worked on was relevant enough to say in agriculture. And I think the initial database contained about 130 ICIs, so initiatives, and in the end, after the validation, like around 99 remain. And this is all written out in a report, and I will share that in the chat as well if you're interested to read further. It's quite an extensive report. Yeah, I hope that answered your question. If there's anything unclear, I'll be happy to answer it.
Thank you. Are there other questions here in the audience? Yeah.
For the next steps, one thing you mentioned was how to engage the private sector.
Yeah.
In that, and you know, we saw your map, and all over the globe, Central Asia is a big area where saline agriculture would make a huge difference. So there's potential there. How to bring it to the private sector, how to convince them? That would be the next question, I guess, one of those.
Yeah, thanks. So in a workshop, we also met with some representatives of these financial institutions. And what came out of that as well is that there's a lot of money available for fighting climate change and climate action, SDG 13. And within that umbrella, you have climate smart agriculture. And that is kind of the buzzword that triggers a lot of these institutions to jump on it. But saline agriculture is such a niche that it's also like an unknown that prevents these institutions from jumping on it. So sometimes it's maybe also a question of branding. Like, do we need to talk about saline agriculture? Do we maybe need to phrase it as climate smart agriculture? What also came out is that maybe a nice first step is to look at microfinance institutions. So how can we set up microfinance funds? And there's usually about a few €1,000 in each fund. Spread over different farmers in a community, and then see how that works. And if that works, then maybe from that case, we can gather the data. We can see there is low risk. 95% of these loans are paid back. Yields are going up. So it's a proven effective business case. And that's also a bit of a data gap that we have now. We have a bit of a scattered data set on successful business cases, but this could be improved. So if we get more economic data on a before and after farm with these saline agriculture measures, and we can prevent that to the private sector, and we can build this arsenal well enough, then I think we can mobilize a bit step by step. And yeah, it's I think it's a slow process. but there are ways to get there, in our opinion.
And are there still some questions online? No? So then I think I would like to thank all speakers and this session. So thank you all for your attention and questions. Thank you. Yeah, so we will be back at 1:30 in the Berlin 1 room for the next stage. That's
1 and 2.
1 and 2.
Oh, it's lunch, do you know?
Now it's lunch, yeah.
Is it around here? Or?
Yeah, just here.
yeah.
I think it will be there where
Yeah,
you
the
came
coffee
in.
was,
Yeah, where the coffee was. Yeah. Yeah.